Let's now consider one of the most important types that Julia provide to us, the arrays. Arrays are an example of one particular kind of types, the parametric types, that allow us to write a generic type and then to specify how it should be parameterized to make an effective specific type. We will see this again when we will deal with custom defined types. For now, what we are interested is just to say that arrays have two parameters. The first one is the type itself that is embedded, so they are collections of other elements, of other objects. These other objects have a type, so arrays are specified with the type of the element that they includes and with the number of dimensions. There is nothing special in one or two dimensions arrays. The first one also are known as a vector. So vector is just an alias for an array of one dimension, as well matrix is an alias for array of two dimensions. So the way they are implemented, there is nothing special for one or two dimensions. However, there are some functions some that accept only one or two dimension arrays. Many linear algebra function, for example, deals with two dimensions arrays or matrix. But in itself, these arrays are also called tensors, are n-dimensional arrays from the start, so it's very powerful. And these, as in some, when the type is a concrete type and is known the bits in each element, for example, integers or floats. Memory can be, the arrays can be a continuous set of memories, and so they are really efficient because they can be read sequentially and they are very, very fast. And let's start to deal with one-dimensions arrays or vectors. So they are treated as a column vector. And as I say, they can be stored and managed efficiently. One important thing is not to distinguish between a column vector of one dimension that we can write in this way with a single column of a two dimensions array that we can write in this way. So in both sense they are column vector. However, this one is an array already with two dimensions, is a matrix, and indeed if you compare them are not equal. So we'll see this one later after we finish the expositions of one-dimensional arrays. Just they are not the same even if they are one single column. We can initialize them in various ways. So we use these square brackets and we put the elements with commas or with a semicolon. In both cases we end up with our array. We can also use ranges or separate elements in this way, and we use for this one the semicolon. And note, so this is a range. And a range we already saw, I think, a range with going from the lower to the high, to an higher value. Here you can see -2. So here this range is taking any value from 6 with a step of -2 going back to 2. So 6, 4, and 3. So at the end, this array here, it is made of 1, 6, 4, 2, and then attached also 10. Put a lot of attention to try to understand well the difference between nested arrays, nested vector in this case, and multi-dimensional array. So here, in this array here, I'm not creating a matrix. I'm creating a nested array where the first element is another array made of 1 and 2, and the second element is another array again made of 3 and 4. So here we have an array of 2 different arrays. I already saw something like this one when we dealt with memory and with object and memory. So there are also several ways to start with empty arrays, but then we want to grow. Even if whenever possible, do not take these steps. It's much better if you already know the size of the arrays to start, and we'll see in a moment, with an array of that given size, and then edit, modify the individual element. But if you have to in your algorithm to start with an empty array, this is the way. You just use brackets, or you specify the type that must go inside, and use the square brackets, like in this case. Arrays can have only one type, like in this case we create an array of integers. You can see vector of integers, but you can put whatever you want inside arrays. And another syntax is this one, and attention to use the brackets here, because otherwise what you are creating is a type. So if I don't use these brackets here, this parenthesis, sorry, I end up assigning to A the type itself, not an object of an array. And as we said that vector is an alias, we can use vector directly. Now, put attention here. So you have a lot of flexibility. However, flexibility sometimes is also less efficient, in the sense that if you create an array of integers of only one type, or a few types when you use a union that we will see, the compiler knows the memory space for each element. So this writing an integer 64 array and then filling is something that is not good, as you already have the full array and you edit your element one by one, but it is still much better than writing like this one, initialize an array of any, and then filling it with integer values. So if you know that all you are going to put in your arrays are integers, start with this one and add your integers. The same for the floats. If you know that all are floats, start with float 64 and the brackets. So you create from the beginning an array of floats 64, and then you add to the array your elements. But put attention to avoid as much as you can to create an array like this with any's, and then add your elements if you know that these elements are all the same. Of course, if your algorithm will have something like that, you are forced to start with an array of any. So we said that it's much better to start to allocate the memory with creating an array of n element in most situations, not always, but in most situations you start with an element array and then you edit them. So let's see how to do. For example, here n3 and the type again is integers. You can create zeros, or you can create and by default they are float, but if you want integers, zeros as integers, you have this syntax here where you specify which type your zero should be. the same for ones. And if you are more general, you want to have an array of n elements but not specifically 0 or 1, you can use this syntax here, and put attention that until you fill it with some elements, what is inside is garbage, is not well defined. If you want to start with, if you know already which element should be, and there should be just one element, you can also use this syntax here to create an array of 3 elements, all filled with whatever you put here as first argument. How do we access vector? Well, let's start with this first to create a vector. Note here the semicolon at the end, otherwise we should on the range, otherwise we would have to use collect, but we'll see in a moment. And note also that when we have a range, this is important, both extremes are included. So here is 100 elements because it starts from 101 and it arrives to 200. This is different, I think, from Python, if I remember correctly. So we have this array. We can just indicate over the bracket the element that we want, or use the keyword AND to define the ending one. And notice that we can also use a vector itself as to indicate the position. So here we are using why there are 2 brackets, because here this one is an array made by 1, by 6, 4, 2, and 10, and we are taking the first, then the 6th, the 4th, and 2, and so on elements out of this array. So we can index an array with individual positions, or we can take a vectors and consider these vectors as positions and index using this vector. As I said, we may use range. So here I'm creating this range that go from 3 to 7 with step 2. So what is interesting of range is that they are not computed, they are not allocated. Ranges are an example of iterators. That is a sort of lazy computation, in the sense that we define how to do the operation, a range define the operation that should be performed, but it doesn't yet do it. To actually take the whole numbers of this range, as you would done with any iterator, you have to use collect. So this collect transform and allocate in memory all the elements of the iterator, a range in this case. So a range is one example of iterator. So what is interesting is that a range that has this type step range, if you see here, is of type, is a subclass of subtype, of abstract array. So class is a terminology of other languages. It's very close to types. You can see here that the type of our range is a subtype of abstract array. What does it mean? What does it mean? It means that everywhere we have a function that require one argument to be an abstract array, so most functions do not require specifically an array, but works with abstract array that is a more general type, and all these functions here will accept, instead of an array that you collect, a range. And this is very important because it postpones the computation and the allocation to where it is really needed. Sometimes you give a big array, but you really don't need it all. You need only a few parts of that. So in this way, if you can never use collect. Use it only when you really need it, because for most operations you can work directly with the iterators, and in particular with a range. Let's now go on to a set of common operations that we can make with vectors. As you can see, it's pretty long. Honestly, I do not remember most of them, so you can always go back to these files here to see them, or to the documentation more in general. So here we have A. We can reverse it, and we have two ways to do it. Either we can use the reverse functions, or we can also use the fact that we can index by a range to start from the last one and going in the other sense, and until we arrive to the first element. In both cases, we reverse the array. A function here is vcat, I don't know. V stands for vertical, because we said that one-dimensional array are interpreted as column array. And by the way, Julia, it works as a column major system differently from Python, but it stores in memory the memory in the arrays that indeed are columns. So it's faster to loop over the different the different column of a matrix, and then the inner you loop over the different rows, because are one close to the other in memory. Then doing the opposite, to loop on every row, and then loop on every column more internally. So if you have to loop over a matrix, first loop over the various column, and then loop over the row. Yes. So here vcat just concatenate the elements in the column. So here we have, should be 1, 2, 3, 4, 5, 6. Push, add an individual element to the array, and append does the same. So what is the difference between these two? Well, the difference in this case you don't see, but you see it when you have you are adding an array to an array, because push add them as a single element. So if here I'm adding this array, this vector of 6 and 7, this vector of 6 and 7 in a vector of vectors. So this is a nested vector where the first element is an array of 1, 2, the second element is an array of 3, 4, 5, and I'm adding this, I am pushing this element here, a vector. Here I am adding it as a single element, so I am adding a vector of 6 and 7, while append go adding each individual element. So here I'm appending a vector of 6, 7. It ends up that I end at each individual element separately. Now you will say, why they have a exclamation point? This is a convention. This is an important convention in Julia, that functions that modify one of or their argument, and in this case we are modifying this argument here. Normally it's the first one, so this array is modified because this vector is added to it. They they are named with a question mark at the end. So this is nothing else than part of the name of the function. You know, in Julia you can use many Unicode symbols, and in particular you can use the exclamation mark as part of the name. So by convention, functions with that ends with exclamation marks, they do modify the first of their arguments. We then have pop that remove one element, so a now is without the 5. Pop first, it do the opposite, it remove the first on the left or on the top if we take the column as convention. And we can also specify at which point to delete, so we delete at position number 2. And what is this one? Pop push first is we add at the beginning of the array. So now we have, let's gonna go back to define our array. We can sort. Notice that many functions have both the version in place and the version that copy and returns a new element. So here doesn't modify a. A has not been sorted if you use sort. Is the output of this function that is a new vector that has been sorted. While if I use the same function with the exclamation mark, it is the vector itself a that has been sorted, but this one just return a copy of the vector without touching the original one. Unique return all the unique elements of the vector. In specific, if some element is like 1 is present, so 1 is in the vector, yes. Length give the number of elements contained in the array, and more in general in all the dimensions. So you have two things here, you have length and you have size. Size return the number of elements split by dimensions. So if we do not specify nothing, we end up with a tuple with just one element, because here a vector is one dimension array. So here we have a common to say that it is a tuple. We'll see tuple just later, but the important bit is that this is split by dimension. If here instead of a vector we would have had a matrix, we would have had two values. And you can also specify that you want the first element in this way. Here is the same, of course, length and size, because there is only one dimension. But again, if you have a matrix, here you will have all the elements of the matrix. So if you have a 2 by 2 matrix, you will have four elements. Another thing that I always forget, the difference between minimum and min. So minimum, take a vector and return the minimum element, while min take multiple argument and return the minimum between them. So minimum take a vector, min take several arguments and compute the mean between the minimum between the different elements that you have. I don't know why they have different names. I always forget. Then what is this one? This is called the splat operator. Splat because it's really splat the value of a vector into multiple elements. So what it does that it take a vector like here, and it transform this vector in 4, 7, 3. So but at this point the correct function to use is min. Of course there is maximum and max as well. Argmin or argmax take a vector and determine which is the position of the minimum value. You have of course sum, and you have cumulative sum, where you have the cumulative sum. To empty a vector, to reset to a vector without element, you use empty. If you want to shuffle the vector to make random positions, you use random and then shuffle, or with the in place version with the exclamation point. You can check if a vector is empty with is empty. Now you want to find where is a vector, where is it, where are the positions of some elements. So let's say that you have a vector of here and you want to know at which position you have a 1. You use this syntax here, and you have 2 and 4 as returned. So what is this? This is a little bit more tricky. So first here you have an anonymous functions that again we will see, but the basic idea is that it's just a normal functions without a name, and this anonymous function go from x to what you do with it. So you compare this x with 1, and where x come from? X is each element of this vector. So this function take this vector, take each element of it, and then apply this anonymous function to it. So you have it compare with 1. It returns a value, an array of Boolean values, 0, 1, 0, 0, 1. So here is 0, 1, 0, 1. And then find all, return the positions of the true values coming out from this function. And you have also, in a similar way, find first. So just to say how this is an anonymous function, you can make a real function here. So my comparison with 1 here is a function that check the comparisons, and and you can pass it here to find all. And this is what is doing exactly the same as before. It take each element 2, 1, 3, 1. Yes, it take and put it in this variable, in this local variable x, and run this function with this local variable x, and make the comparisons that we did here. So this is exactly the same as this one. Let's see how to delete some data. So let's see that you have one big array of data. You want some specific data to delete. Well, you use a combination of delete all and find all. So find all give us the position of the data to delete, but when x is in the array of values to delete. So here we end up with the positions of this data that we want to delete, and we say delete data at these specific positions, and you end up with a vector without the data you want. You can use other 1000 other ways for doing that. Two important things yet. So when you loop over data, very often you want to know the positions and the values. So you loop over this array, and you want at the same time know the position 1, 2, 3 and the value 10, 20 and 30. And for doing that you use enumerate. So we'll see 4 loops in the taste, but this is what they are doing. Enumerate is a functions that return at the same time the position and its value. So here we have the position and the value. Another very common operation is to zip together some data. So here we have an array with names, mark n, an array with sex, the corresponding sex for mark and n, and an array of age. and we want to find a way to get the first element of names together with the first element of sex and the first element of age. And for doing that, we use the function zip. So zip put together the same position element from each of the argument that is run with. Of course, you don't need it. You can do manually in many other ways, but it's a very convenient functions to use often. So here you end up with the first element returned by zip is the first element from names, the first element from sex, and the first element for age, and the same for the second elements.